You are all welcome for our sixth presentation, and in this particular presentation we shall continue looking at the different kind of ways that atoms interact with one another in atomic structure and bonding. Today our focus is going to be on molecular orbital theory. The salient features of this theory are that the electrons in a molecule are present in various molecular orbitals, as electrons of atoms are present in various atomic orbitals. The atomic orbitals of comparable energies and proper symmetry combine to form molecular orbitals. In a molecular orbital, electrons are influenced by two or more nuclei present in the molecule. Thus, an atomic orbital is monocentric while a molecular orbital is polycentric. Under the molecular orbital theory, the number of molecular orbitals formed is equal to the number of combining atomic orbitals. When two atomic orbitals combine, two molecular orbitals are formed. To understand this clearly, we are going to have a focus taken back to our studies of waves. I will give you an example of waves that normally are visible, say on a water surface. When waves are moving, we normally have a certain direction they move to. And if a wave is moving to a certain direction, you actually see the troughs and the bends moving as the wave moves. But if we have, say for example, another wave moving in the same direction and it comes into contact with the first wave, normally if they are in phase, the resultant wave is a bigger wave, a wave of big amplitude. So waves can combine. If they are going to combine, we are saying if they are in phase. What is meant by being in phase? If in a particular wave the particles are vibrating in the same direction as the other wave, they are in phase. But if they are vibrating in opposite directions, the waves are said to be out of phase. If we think about our atomic orbitals being like waves, we are saying when one atomic orbital combines with another atomic orbital, there is a tendency of forming a bond or molecular orbital in which we have more likeliness of bonding, and therefore we say it is a bonding molecular orbital. In case, for example, the kind of atomic orbitals tend to be of opposite nature to one another, whereas actually there has been an overlap, what forms then is a molecular orbital with unlikeliness, a large unlikeliness of forming the bond, meaning that there is a tendency of not bonding. Therefore, what comes out of this is that the bonding molecular orbital is when we had these atomic orbitals being in phase. When they are out of phase, what is formed is anti-bonding molecular orbital. The bonding molecular orbital has lower energy and hence greater stability than the corresponding anti-bonding molecular orbital. The electron probability distribution around a group of atoms in a molecule is given by a molecular orbital. The molecular orbitals, like atomic orbitals, are filled in accordance to the off-bow principle, obeying Pauli's exclusion principle and Hand's rule. The types of molecular orbitals, we have the following. Molecular orbitals of diatomic molecules are sigma, pi, and delta. The sigma molecular orbitals are symmetrical around the bond axis, while the pi molecular orbitals are non-symmetrical. The pi molecular orbital has larger electron density above and below the internuclear axis. The pi antibonding molecular orbital has a node between the two nuclei. Hydrogen bonding. The highly electronegative elements like oxygen, if they can be attached to hydrogens, say for example hydrogen, we are going to find the following. When the highly electronegative elements are attached to hydrogen atom, they form a covalent bond. We gave an example of oxygen hydrogen, where we said oxygen has a very high electronegativity value compared to hydrogen. And because of that, the kind of bond that was formed between oxygen and hydrogen, we said the following, that the bond is going to suffer unequal sharing of the bond electrons. They tend to reside closer to oxygen than hydrogen. And earlier on we said that therefore hydrogen will tend to be having a deficit in electrons. Therefore it tends to acquire a partial positive charge, and the oxygen acquires a partial negative charge on it. For that matter, the electrons of the covalent bond shift towards the more electronegative atom, in this case oxygen. And since we have said this creates partial charges on the atoms involved, if we then view the oxygen hydrogen atoms, they will be having greater tendency of shared electrons closer to oxygen. Overall, the oxygen has a partial negative charge and the hydrogen atoms have partial positive charge. When these water molecules are in, say, for example, in a container and close to one another, there is a relationship that results between oxygen of one molecule and the hydrogen atoms of other water molecules in the container. That relationship is what we call a tendency to have some attraction, partial attraction between partially positively charged hydrogen atoms and, say for example, the more electronegative oxygen atom. This is what is known as the hydrogen bond. Hydrogen bonding. Causes of formation of hydrogen bond. When hydrogen is bonded to strongly electronegative element X, the electron pair shared between the two atoms moves far away from hydrogen atom. As a result, hydrogen atom becomes highly electropositive with respect to the other atom X. Since there is a displacement of electrons towards X, hydrogen acquires fractional positive charge or partial positive charge, delta plus, while X attains a fraction negative charge, delta minus. Hydrogen bond can therefore form between the X of one molecule and the hydrogen of another molecule of XH. Hydrogen bond is weaker than the covalent bond. There are two types of hydrogen bonds. Intermolecular hydrogen bond, like the one I've been discussing before, between two different molecules, and intramolecular hydrogen bond, which is formed between a hydrogen atom and the other highly negative electronegative element, or the other highly electronegative atom present within the same molecule. What we have here is that we have come to the end of sessions. I acknowledge the sources of ideas and information used in this presentation, and particularly in all the presentations we have had. You are requested to work and discuss the practice questions in your various groups. Remember, we said that we must use maximum cooperation, minimum effort. Therefore, cooperate maximally and take records of your study. This presentation summarizes the course unit. Thank you very much for your attention. See you soon.